Hey there, Python trainer Reuven Lerner here, and this time I want to talk to you about mutability and strings and where people sometimes get it a little bit wrong. So let's start off with some basic definitions. If I say s equals a, b, c, d, e, I can of course get the value of s at index 0. That comes back to me. What if I try to change that? What if I try to say s of 0 equals exclamation point? That is not going to work. We get an error. And what Python says is string objects do not support item assignment. What it's really trying to tell us, though, in more Pythonic language is strings are immutable. They can never, ever change. Now, people are a little surprised by this sometimes. They're like, well, what do you mean strings can never change? I can change them. And I then say, okay, how do you think you can change it? And they say, watch this. I can say s, which of course is a, b, c, d, e, s dot replace of c. And well, actually, we need to say C, and let's call that C of exclamation point. And C, now we've changed S, to which I say, no, 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 we've not actually changed S. S remains exactly what it is. We got a new string back based on S, right? And so we can do that as many times as we want, but it's not going to change S. If we really want to change S, we need to assign the new string back to s. So if now I say s equals s dot replace c with exclamation point, now we look at s and sure enough it has changed. And yes, I realize that here I'm replacing index 2 and there I was replacing index 0. Stay with me. Okay, so we can't actually change a string, but we can assign a new value back to s. And that's often hard for people to understand because immutable does not mean constant. Constant in many languages means that there is a permanent, unchanging relationship between the variable and the value, that this variable will contain this value forever. Python does not have that idea. We talk about having constants, but we don't really have constants. Rather, what we have are variables, and we can assign whatever we want, whenever we want, to any variable in the system. Okay, well, what about this? What if I say s equals a, b, c, d, e, and then I say s plus equals f, g, h, i, j? See, I was able to change the string s, and I see this and hear this from people all the time. But it's way more subtle than that because we are not actually changing the string that s is referring to. We are instead creating a new string and assigning it back to s. How do I know? How can I check this? Well, if I say s equals a, b, c, d, e, I can actually get the ID of s. What is the unique object ID of the item, the string, that s refers to? And that is going to be this long number here, which, by the way, I should add, is the address in memory of the object that s refers to. So that string is located at that location in memory. We can't actually access that memory directly because this is Python and not C, but that's okay. So if I now say s plus equals fghij, this is, of course, being translated into s equals s plus fghij. And so what's happening here? We are creating a new string. We're creating a brand new string with a brand new ID, and then we're assigning that new string back to s. So if I look at s, it looks like, oh yeah, I've changed it. But of course, if I now say ID of s, we see that we have not changed the string. We see that we have a completely and utterly new string here, right? The old string no longer is available to us. Now, what happens to that old string? Well, Python has a garbage collector, and the garbage collector system looks at how many references, how many variables, how many other places in Python are referring to that object. And when the object has 0 references, then it is released. Maybe not right away. The garbage collector can sometimes take some time, but in general, you can be confident that when you no longer have references to an object, the garbage collector will take care of it. You're not going to have a memory leak from this. At least you shouldn't if all goes well. Now, I'll add that for strings, it's a little trickier than that because short strings are actually cached in Python using something known as interning. We're going to ignore that for now. We're going to assume that all objects are garbage collected pretty quickly as necessary. But my key point here is that the string hasn't changed. We have switched to a new string. Okay, that's a subtle point, so I'm going to say it again. The string has not changed. S is now referring to a new and different string. The effect is, of course, what we would want and what we've talked about. Now let me prove this to you in another way. If I say here s equals a, b, c, d, e, and then I say here t equals s, So this means T refers to the same object as S. So now if I say, what's the ID of S and what's the ID of T, both of them refer to exactly the same object. And now I say S plus equal, hello out there. Now the ID of S has changed and the ID of T remains exactly the same because T continues to refer to that same string as before, whereas S is now referring to a completely different string. So can you use plus equal on strings? Yes, but you are not changing the string. Rather, you are having the variable refer to a new string. And I'll just add one or two more points to this. If you do something like this, if you say, S equals empty string for one item in, let's call it, let's just do this, for I in range 10. And I'm going to say here S plus equals the stir of I. What am I doing here? With each iteration, I'm creating a new string and assigning it back to S. And sure enough, at the end there, S will be all the digits 0 through 9. That seems great, but think about it. I just created 10 strings only to throw them away. And each string was a little bigger than the previous one. I had 0, then 0, 1, then 0, 1, 2, then 0, 1, 2, 3, and so on and so forth. Imagine doing that 1,000 times. Imagine doing that 100,000 times. That's incredibly wasteful in terms of memory. And so in general in Python, you should not be using plus equal on strings in a very large loop or even in a medium-sized loop because you're creating so many interim strings, it's just wasteful. Instead, what you should do is you should create a list. You should say your my list equals this for I in range 10. My list append of stir I. And then I can just say join of my list. Now, what's the difference? The difference is that lists are mutable. They are designed to be added to. They're designed to be changed over time. And so their memory management is a little smarter when it comes to adding things to them. We're not creating a new list with each iteration. We are adding a new element to the existing list. And only at the end are we creating a string. I actually did a project so many years ago in which I really got into trouble because I was going through a database of 100,000 records. And I was doing this sort of thing with plus equal with strings, and that used a ton of memory. The moment that I switched to using a list and append and then join, bam, it was way, way, way faster and used way less memory. So you should definitely try to consider that. Okay, I hope you now have more insights into plus equal and strings and immutability. Please, if you have any questions, want me to discuss any topic, get in touch with me. Contact me on email or on Twitter, where I'm very active. Also, don't forget that I send out free weekly updates and newsletters and articles about Python. Just subscribe to that along with about 25,000 other people at betterdevelopersweekly.com. Thanks a lot for watching, and I'll be back real soon with another video.